Hello and welcome to section 2-2, day 2. We're going to be talking, or I'm going to be talking about symmetry and the three different types of symmetry that we're going to be studying here. So what you might want to do is just take some time to pause this video and write down basically what you see on the screen. I'm going to go ahead and talk a little bit about each of these types of symmetry with the next slide here. You've got symmetry with respect to the y-axis, with respect to the x-axis, and with respect to the origin. So those are the three types of symmetry that we're going to be exploring here, with respect to the y-axis, the x-axis, and the origin. Giving you a graph, a visual of this, if you start with that symmetry with respect to the y-axis, a good example of this would be maybe a parabola. Okay, if we have this beautiful parabola, if you notice here, this is symmetric with respect to the y-axis, meaning that it's the same on both sides of the y-axis. Well, I want to point something out. With this, if you kind of look at the notes that you've taken so far, right here you see the coordinate 2, 2, and over here you see the coordinate -2, 2. By definition, that's what this whole symmetry means, is when you have symmetry with respect to the y-axis, then for the same x value, you get 2, and if you get the negative of that x value, you also get 2 for the y value. So in other words, opposite x values, both the positive and negative of the same x value, has the same y value. So what you might want to do is kind of go back to this and say that there's a test for symmetry with respect to the y-axis, and if you substitute a negative x for x, that'll tell you within an equation that you're going to be given, and this will make sense as I start working through some examples, that would tell you whether or not there is symmetry with respect to the y-axis. The second type of symmetry is with respect to the x-axis. And an example of that would be maybe a sideways parabola would be good. So here we have a graph that looks kind of like this. And if you look at this, I've got this coordinate here, which is 1, 1, and I've got the coordinate, 1, -1, where opposite y values have the same x values. So if I apply that to a test that we can run here, the test that you can use for symmetry with respect to the x-axis is to substitute a -y for the positive y. A test that we can run for the origin, if you notice here, both the x and the y are negative. Now, let me give you an example of that. For respect to the origin, well, if you've got this graph, I'm going to draw the graph of y equals x cubed, okay, where you see this coordinate here at 1, 1, and you see a coordinate down here at -1, -1. Well, both of the x's and y's are exactly opposites. So the test for this would be to substitute a -x for x and at the same time -y for y. So you make both the x and the y negative. Now, right now you may be thinking, I have no idea what you're talking about. Just be patient. Let's take this equation. Okay, we're going to test this equation for symmetry, those three types. There's symmetry with respect to the y-axis, with respect to the x-axis, and with respect to the origin. And what I'm going to do is those tests for each of these situations. The test for the y-axis was to make the x negative. So what I'm going to do is I'm going to rewrite this equation, and instead of an x, I'm going to replace that with a -x. Okay, the y I'm just going to keep the same. If you look at this, if you square a number, that actually gives you a positive value, or any even power will make that a positive value. So that if we square that, you get x squared minus y cubed equals 2. Now notice how that equation is exactly the same as this equation. That's the test right there. Since that equation is the same, then there is symmetry with respect to the y-axis. I'll say a check mark, or I can say yes. I'm going to do something later to finish that up. To check for symmetry with respect to the y-axis, what you can do is make the y negative. So I'd get x squared minus -y cubed equals 2. Now notice here, if you take a negative number to an odd power, that actually gives you a negative number. So what we have is x squared minus a negative y cubed, which is the same as plus y cubed. If you need to, you might want to rewind this and replay that section again just to kind of hear what I said there. Notice how this equation is not exactly the same here. So there is not symmetry with respect to the x-axis. Checking for symmetry with respect to the origin, what we do is we're going to make both the x and the y negative. And we're going to see what happens. So if we do that, if we square the negative x, that does give us a positive x squared. If we cube the negative y, that actually gives us a negative y cubed, but then we subtract that, so that becomes plus y cubed. Again, this is not the same as the original equation, therefore there is not symmetry with respect to the origin. The only one that worked was the y-axis. So I would say there is symmetry, and I just write this with respect to the y-axis. That's the only one that passed. So that's where there is symmetry. I want to give you one more example. This equation, x squared minus y squared equals 10, and I'm going to check for the symmetries again. Let's start with the y-axis. To check for symmetry with respect to the y-axis, I'm going to make the x negative, okay? And I'm going to see what happens. Well, notice if you square a negative number, that gives you a positive number. That is the exact same equation as the original, so that works. I'm going to test with respect to the x-axis. So I'm going to make the y negative. Now, exponents come before subtracting. So as I square that negative number, that gives me a positive. So I have x squared minus y squared equals 10. Again, that's the exact same as the original equation. So that worked. I'm going to check for symmetry with respect to the origin. So I'm going to make both of these negative. Okay. And oops, there's a negative in there. As you may have guessed, that is also going to work because if you square a negative x, that gives you x squared. If you square a negative y, that gives you a positive y squared, and that's the same thing. So there is symmetry, I'm going to abbreviate here, with respect to, and you would just list these, the y-axis, the x-axis, and the origin. Has all three of them. All right, so and there are even cases where it might be none of them. So know that there are all kinds of different possibilities that you can have. All right. I know that was kind of fast, but if any questions, it doesn't hurt to go back and replay some of these just to hear it over again.